Let's do some examples from the day 35 assignment. Here we'll be solving rational equations. When you look at the notes say to simplify each side individually so that we can create a proportion. In addition to that, if you want to, advance ahead, you can also go ahead and start leaving your denominators in factored form. So a proportion is just when one fraction is equal to another one. I have one fraction on each side. So the left side is already complying. The left side is ready to go. But the right side is not. I need to go ahead and add fractions like I did 2 classes ago. So in order to add fractions, I need the least common denominator. The least common denominator is going to be x minus 7 and x minus 3. It just happens to be a complete coincidence that when I factor this first denominator, I also get x minus 7 and x minus 3. But that's just a coincidence. We're treating the two sides completely separate. One has nothing to do with the other. Now on this right side, I'm going to have LCD, x minus 7, x minus 3, over, plus, and then x minus 7, x minus 3. The first fraction was missing an x minus 3, so whatever was on top times x minus 3. The second fraction was missing an x minus 7, so whatever was on top times x minus 7. I'll write the second fraction exactly the same. I want to leave my denominators factored. And I could now accomplish what I wanted to here, which was to have a single fraction. I can bring the denominators together. Since I'm adding, I could just say, 6 times x minus 3 plus 5 times x minus 7. And so x squared minus 29 over x minus 7, x minus 3 is equal to 6x minus 18 plus 5x, I'm just distributing, minus 35 over x minus 7, x minus 3. I'll go ahead and combine like terms, so x squared minus 29 over x minus 7, x minus 3 equals 11x minus 45 minus 53 over x minus 7, x minus 3. All right, so I have my proportion exactly the way I wanted it. Now you've learned in the past that in order to solve a proportion, you should cross multiply. If two fractions are equal, their cross products are equal, and that's true. But in a rational equation, since you have variables involved, that could cause some headaches with your degree. For instance, look at this cross product here. I'd be multiplying two different quadratic polynomials, and a quadratic times a quadratic would give you a fourth degree. Right? I'd have a fourth power. This way, I'm multiplying a linear times a quadratic. I would have a third degree. So my biggest exponent in all would be a fourth power. I'd have to solve a fourth degree equation, which we'll work on, or I'm sorry, we have worked on. We've when we solve polynomial equations, but they weren't fun. So not that it guarantees you to have the smallest, that you're going to have a small degree, but a way to keep your degree as small as possible is now for the first time we'll consider both left and right side together, and we're going to take the LCD from both sides. In this particular example, they're exactly the same. So my LCD here is x minus 7, x minus 3 because they have the exact same denominator, but I'm going to use it differently. I'm not going to use LCD to add or subtract a rational expression. I'm going to use it to cancel the denominators. I'm going to multiply both sides by that LCD, x minus 7, x minus 3, and then over here I can't squeeze it in, but x minus 7 and x minus 3. So I can do whatever I want as long as I do it to both sides. You saw when we multiplied that now I can get these factors to cancel. So what I'm left with now is an equation that says x squared minus 29 is equal to 11x minus 53, and that's just a quadratic equation. Okay? Because it's quadratic, I have to put all the terms on one side. So minus 11x plus 53 plus 53. These all cancel out. So I have x squared minus 11x. Negative 29 plus 53 is plus 24. At this point, I can now solve by either factoring or by quadratic formula. Anytime I have a lead coefficient of 1, I'm always tempted to do factoring, and that's what I'm going to go with here because off the top of my head, I know that two numbers that multiply to give me 24 that add up to negative 11 are negative 3 and negative 8. So I could just say x minus 3 and x minus 8. Zero product property says that x minus 3 can be 0, x minus 8 can be 0, so x can be 3, and x can be 8. But, as you can see here from the format, these are the solutions to a quadratic equation. They're not necessarily the solutions to a rational equation. So the way I could do this, I need to do what's called checking for extraneous solutions. The way you check any equation is you could get the solutions and plug them back into what we had at the beginning. But there is a shortcut for rational equations, so I'll show you the shortcut. The shortcut is to compare your solutions to your restrictions. So right now I have solutions of 3 and 8. 3 and 8 really want to be these unknown numbers. Please pick me. I'm the one that makes your equation true. But we also have restrictions that state what x and y can be. Now restrictions come from a denominator, and since I had a step where I needed to find the least common denominator of the entire equation of both sides, I know that the only factors that were in the denominator were, from up here you can see, x minus 7 and x minus 3. So x minus 7 is not allowed to be 0, and x minus 3 is not allowed to be 0. So x can't be 7, and x can't be 3. If any of my restrictions disagree with any of my solutions, the restrictions win out. So since x wants to be 3, but my restriction here says that x can't be 3, this solution is said to be extraneous. It does not count. You would not include it if the directions here just said solve. All you would say is that x is equal to 8, because the only other restriction is 7, and that doesn't match up. If for some reason this last restriction would have been 8, and 8 wasn't allowed either, then guess what? This equation would have no solution. But this equation does have a solution. If this is a test or a quiz and I'm asking you to solve, that's all you're going to do is just tell me the 8, x equals 8. There is no need to say anything ever about an extraneous solution unless you're specifically asked for it. This particular question does ask me for the extraneous solution, so I'll write it that 3 was extraneous. But what's more important is that x, the unknown number I was looking for that makes the equation true, is 8. Here's another rational equation. I want to turn this into a proportion. My right side is all set to go. I have a single fraction, but I need to turn the left side into a single fraction. I do this by factoring the denominators. So this first denominator is 2 times x plus 4. The second denominator just stays at 6. And over here on this side, I'm all set to go. I could factor the denominator in anticipation for the steps to come, but x plus 6 cannot be factored, so that's just going to stay the same. My LCD on this side with the 2 and the x plus 4 is going to have to be there. But with the 2 and the 6, I don't need both the 2 and the 6 because I know that 6 is both a multiple of 6 and 2. So my LCD is just 6, and then the I wrote x plus 6. I was thinking of too many things in my head. It should just be x plus 4. Sorry, x plus 4 minus 6 times x plus 4 equals 2 over x plus 6. So this first denominator, to turn from where it started into this one, it was times 3. The x plus 4 stayed the same, but it was 2 times 3, so 5 times 3 is 15. The second denominator, I multiplied times x plus 4. 1 times x plus 4 is x plus 4. Now I can bring these together, 6 and x plus 4. 15 minus, but I have to keep the x plus 4 in the parentheses because that minus wants to change the signs. So I'll now rewrite the top. 15 minus x minus 4 over 6 times x plus 4 equals 2 over x plus 6. And finally combine like terms and we get 11 minus x over 6 times x plus 4 equals 2 over x plus 6. So now I'm ready to go. I have my proportion. This one wouldn't be too bad to cross multiply because the biggest cross product would yield a quadratic expression, a quadratic polynomial, and that's not too bad. But just to get into the habit, let's keep things the same. Let's multiply by the LCD. Let's find the LCD of all denominators that are left, of both of them. The LCD there would be the 6, the x plus 4, and the x plus 6. I need all of them. 6 times x plus 4 times x plus 6, multiply over here. 6 times x plus 4 times x plus 6. On this side, I can cancel out the 6 and the x plus 4, but the x plus 6 stays around. On this side, I can cancel out the x plus 6, but the 6 and the x plus 4 stick around. So I have x plus 6 times 11 minus x is equal to 12 times x plus 4. 2 times 6 is 12. Here, I would FOIL. Let's go. X times 11 is 11x. X times negative x is negative x squared. 6 times 11 is plus 66, and 6 times negative x is negative 6x, and this is equal to 12x plus 48. I have a quadratic equation. I want to move all the terms to one side. If I have any like terms, I would combine them. I do have some like terms. I have 11x and 6x is 5x, so I would write here negative x squared plus 5x plus 66 is equal to 12x plus 48. Because the x squared is negative, let's choose to move everything to the right. So plus x squared minus 5x minus 66. Plus x squared minus 5x and minus 66. All of this cancels. So I have my 0 is equal to positive x squared plus 7x. 48 minus 66 is negative 18. Did I do that right? Negative 18. Yeah, I think that's right. So, okay. Let's go back and erase this to have some space. Again, I could use quadratic formula if I want, but anytime I have a lead coefficient of 1, I'm always tempted to factor. And here I can because positive 9 times negative 2 gives me negative 18, but when I add them, I get 7. So zero product property says that x plus 9 can be 0, x minus 2 can be 0, so x can be negative 9 and x can be positive 2. But these are the solutions to a quadratic equation, not necessarily a rational equation, and we were asked to solve a rational equation. So the more generic way of checking would be to get each one and plug them into these x's when it was still rational and see if they work out. But that can be quite tedious and take a long time. So the shortcut is to identify any restrictions and compare your restrictions to your solutions. So looks like I erased it by mistake, but I still have it over here. The restrictions come from your LCD. So my LCD here was x plus 4 and x plus 6. So I know that x plus 4 can't be 0 and x plus 6 can't be 0. So it means that x is not allowed to be negative 4 and x is not allowed to be negative 6. We weren't asking for x to be negative 4 or negative 6. None of my restrictions match up with my solutions, so I'm allowed to keep both solutions. So this particular this particular rational equation has two solutions. Those solutions are negative 9 and also positive 2. And let's see, last one. Okay. Let's solve this rational equation. The right side looks like it's ready to go. I could factor that denominator, and I will, but my work primarily at the beginning here is to subtract these, subtract that rational expression on the left side. In order to subtract, I need to factor. So 5 over, this is going to be x minus 1 and x minus 2 minus 1 over x minus 2 is equal to x plus 6, and even though I'm getting ahead of myself, I'm going to go ahead and factor this already and say 3 times x minus 1. I factored out a 3. Back to the left side, my LCD here is going to be x minus 1 and x minus 2. Any factor that's on the bottom needs to be part of your LCD. Notice how even though the reason why there's an x minus 1, x minus 2 is not because of this x minus 1. I don't care about what's on the right side. It's because of the one over here on the left. If I cared about the right side, you would see a 3 down there right now. I don't need the 3 right now. There is a way that you can do it. I just don't advise it because I'd rather do one step at a time. But I mean, you could, when finding this LCD, you could already go ahead and just make all the denominators the same. But that's up to you. This first denominator stayed the same, so the 5 stays the same. The second denominator has an x minus 1 that wasn't there before. 1 times x minus 1 is x minus 1. I can now bring these together, but that subtraction wants to change your sign, so I'm going to leave the x minus 1 in parentheses. X minus 1, x minus 2 equals x plus 6, and then 3 times x minus 1. I'll let that negative go ahead and change my signs. 5 minus x plus 1 over x minus 1, x minus 2, and that is equal to x plus 6, and 3 times x minus 1. So when I combine, I get 6 minus x over x minus 1, x minus 2 is equal to x plus 6 times 3 times x minus 1. So I want to solve now, but instead of cross-multiplying, what I'll do is I'll multiply both sides by the LCD. The LCD of these two fractions is the 3 that has to be there, x minus 1 and x minus 2. So 3, x minus 1, and x minus 2. So now I can cancel out. On the left side, the x minus 1 and the x minus 2 cancel, but I'm left with the 3. On the right side, the 3 and the x minus 1 cancel, and I'm left with the x minus 2. So I have 3 times 6 minus x is equal to x plus 6 times x minus 2. So I get 18 minus 3x is equal to x squared plus minus 2x plus 6x minus 12. This is a quadratic equation. Eventually, I would want all terms to be on one side, but let's combine the like ones first. X squared plus 4x minus 12. Since the x squared is positive, I'll leave it on the right side. So plus 3x and minus 18 plus 3x and minus 18. So I get 0 is equal to x squared plus 7x minus 30. Let's make some space, so erase this side over here. Because the quadratic equation is equal to 0, if you want to use quadratic formula, you can. But anytime I have this 1 out in front, I'm always tempted to factor. So can you think of two numbers that multiply to give you negative 30 and add up to 7? I can. That is x plus 10 and x minus 3. That gives me 0. So x plus 10 can be 0, or x minus 3 can be 0. Minus 10 minus 10, so x can be negative 10, plus 3 plus 3, so x can be 3. But again, these are the solutions to a quadratic equation. I need to see if there are also solutions to a rational equation. So I need to compare my solutions to my restrictions. Over here, when I found the LCD of both sides, and on the bottom I had an x minus 1, that's not allowed to be 0, and I had an x minus 2, that's not allowed to be 0. So my restrictions are that x can't be 1 and x can't be 2. When I compare my restrictions to my solutions, everything checks out. There is no conflict, so I can keep both of my solutions. My solutions are negative 10 and positive 3. And that's correct.